Hey students, so today we're going to continue with our circuits and we're going to learn the difference between the definitions of a series versus a parallel circuit. We're still going to use our squishy circuits with our Play-Doh and our modeling clay because remember from last lesson that the Play-Doh was a good conductor because it has charge and carries electrons through the dough, where the modeling clay is an insulator and does not allow electrons to flow. That's the same as the wiring that we have here. On the outside is the plastic. It does not allow electricity to flow. The inside is the copper wire, which allows the electrons to flow. Conductors, the copper on the inside of the wire, and the plastic on the outside is the insulator. So what we have here is our blue Play-Doh. These are all the conductor. And then the yellow modeling clay is the insulator and does not allow the electrons to flow. So let's go ahead and dig in. Let's look at our paperwork that I want you guys to fill out as I do this. Again, just go ahead and follow along and fill out wherever there's a red little star, or I point out like, hey, let's answer this question together. I want you to do that, okay? All right. Okay, students, so you're right back here on this first part of the worksheet. I want you to notice that you've got your essential question or daily learning objective. Anywhere there's a highlight or a red star, I'd like you to make sure you write that down in your notes somewhere. If you don't have to print anything out, but just, make sure you're getting down the important key points that we're covering, okay? So, our first thing is, what is the difference between a parallel circuit versus a series circuit, and why would we use both? And that's important because we're going to get to solar photovoltaics, and we actually use both of the wiring types for parallel versus series when you do the solar photovoltaics. All right, now the key terms are actually things that we already went over in the last activity, and so these things should look familiar to you. Closed circuit, remember that's when the door's shut and the wires are all connected and the electrons can flow and the lights can light up, or whatever electronics you're trying to use can light up. Open circuit would be like if you have the light switch turned off. Closed would be if you have the light switch turned on. And so the off switch in your houses actually means that there's like an open door sort of thing and the wires are not connected. Short circuit, as we said, if the Play-Doh touches or the insulators touch and you don't want them to, like there was supposed to be an insulator, or I'm sorry, if the conductors touch and there was supposed to be an insulator in between, then that could cause a short circuit. Look at our last video because I don't want to take too much time reviewing that. These are the new things that we're going to learn today: series circuit, parallel circuit, and we've already gone over voltage, but I do want to remind you that voltage is the pressure behind electrons making them move. Additionally, resistance, write that down. Resistance is something that slows the electricity down from moving, and then current is the electron flow. Okay, so let's just go ahead and dig down into our very first definition, which is a series circuit. I think the image says it all. If you could draw a series circuit right now, that would be awesome in your notes. A series circuit is sort of like a single lane highway. Remember, I like to use the cars on the freeway analogy for understanding electricity, like electrons are the negative little dots that move. And then this wiring is like the road. So as you can see, a series circuit does not have options. It's just a single lane highway, okay? So what type of limitations do you think that's going to cause? One thing you might want to think about is if we're lighting all these light bulbs up on a single lane highway set up for series, then what happens if this light bulb goes out? That would be sort of like a traffic accident on a single lane highway. We've all been there. That's a nightmare, right? You can't get through. So series, you probably right away know like, oh, bad thing about series circuit for wiring. If you've got something that goes out or stops functioning or a blockage in part of your circuit, it actually shuts down the whole circuit. So that's not a good thing. All right, guys, please, I do want to remind you to look at these closely on the dock that I shared, because I know this is really bad lighting. Unfortunately, it's raining, so I'm doing this inside today. Anyways, here's a parallel circuit, and I really love the imaging because you can see clearly the difference. Here's our series, here's our parallel side by side. Obviously, we've got parallel lines, that's why it's called a parallel circuit. And so you have multiple options, and you see that in the arrows, okay? The electrons could go down the first light lane, they could go down the second or the third. And right away, we see the difference between why we'd want to wire something like this. So if we've got a blockage right here, the whole strands of lights do not shut out. The electrons can go through a different lane, and this light bulb and this light bulb would still light if this one goes out. If this one goes out, these two would still stay on. If we're comparing it to series, this one goes out, they all go out. So parallel is like a parallel lane highway, and that's why they make parallel lane highways, that they have a lot better traffic flow through those lanes. I do want you guys to make sure you do, this is sort of a comparison side by side, and you have better visibility on my document that I shared with you to copy all these things down. I'll quickly go through them, but again, you guys can quickly copy these notes down off of the doc and see it a lot better. So I'm just going to just briefly breeze through this. So again, parallel versus series, what's the difference? In a parallel circuit, the positives, one light goes out, the other two lights stay on. The second positive is that the three waterfalls, and I'm talking about these three lights being sort of like three waterfalls, because as we've talked about before, electrons flowing is similar to little water molecules flowing. So we could have three different series of waterfalls in a parallel. They're all side by side, and all flow with the same electron water flow, and the pressure is all the same. And we call this voltage. So the voltage pressure across the drops of all the lights inside of a parallel circuit is the same. So that's good. The negatives here, though, is that the battery will die quicker because the voltage gets used up, because you're now feeding the same voltage through three different things, not just one. All right, moving on to the single lane highway series circuit. The positives, number one, the batteries last longer because there's not as much voltage or pressure being used as quickly, because it doesn't have three of them being used all at the same time like the parallel. The negatives is that the waterfall, quote quotes, are all under each other, and it starts strong with the bright light at first, and you'll see this in the lab today. But the waterfalls of electrons moving through them slowly fade and die, okay? So here's another image of that I could draw it for you, is that the electrons are stronger at first through the first light bulb, then a little bit less in the second, and then even fainter in the third. So when we're gonna see our light bulbs today, what we're looking for when we do our labs is bright, 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 all the same. In a parallel series, it becomes bright at first, medium, slowly fading, maybe even dying. Okay, that's a negative. We like these to be bright all the time with parallel, but the battery dies, right? The battery doesn't die as quickly, but it's not the same shininess. That's not good, especially if you're doing Christmas tree lights. Christmas tree lights are in parallel, and then sometimes they'll series them like in chains. And so you might find there's a long strand of lights that you would have to look to see if maybe like three of them are linked together through series. And so you have to check all of the lights, because then they're also series in it's a mixed circuit is what we call it. We'll get to that later. Anyways, nowadays though, the Christmas lights are not series. When I was growing up, they were all series. And if one light went out, the whole tree went out, and we'd have to go find it. And so now they do the parallel, but they do sometimes daisy chain them in together. So if you do see like a chunk go out, that means there's a chunk of series that have been paralleled together, if that makes sense. Again, that's a mixed circuit. Okay, second thing about series that is negative is that this also means that not all lights in series have same voltage or pressure behind them. That's what we said, there'll be different intensities of light. And the third thing that's negative is obviously the number one almost in your mind. One light goes out, they all go out, okay? So that's our comparison side by side. Copy those down from your notes. Okay, moving on to our lab activity. We're gonna go ahead and start first with our squishy circuit, making a series circuit. So they will be all in a single lane highway concept. We're gonna make this caterpillar looking thing. And then we're going to answer the questions in our reflection. So I'll try to hybridize it for you. I might just verbally read and answer the question for you guys, and then come back and try to sum it up. I don't know, I'll try to mix it up a little bit. Okay guys, so now we're actually building a series circuit. As you can see, we've got our caterpillar, conductive blue dough, insulating yellow dough, and we've got only one light connecting the single lane highway. Again, we have the red side that has to match up with the longer side of the LED, so I made sure that that long side went this way. If I were to turn this around, I'm just reviewing really quick. It doesn't light up because of polarity. LEDs are one directional. The electrons have to flow in a certain order. So there we go. So light. First question says, what intensity is that light when you only have one light on a series circuit? So we've got the black wire coming off the blue second caterpillar link, and the first one is the red. We've got a circle closed circuit here going on. Light is bright. So answer that question in your reflections in your notebook. All right, now we're going to add a second light. So I'm gonna take out the wire, the black wire, and I'm gonna move it to the third ball. And then I'm gonna, make sure that the longer one goes in. And actually that's lit. So what do you notice right away? We have a dimmer. We add 2, it gets dimmer, much dimmer. It was very bright with just 1. Here we put 2 and it's a lot dimmer. Okay. So that's the answer to question 2. Now, question 3, we're just gonna keep adding until it stops. So I'm gonna move this circuit over to the end. I'm gonna add one more, again, directionally aware, longer one on that side. And we've actually, achieved that final question where it says keep adding until it won't light anymore. Just to prove to you that it's not the light bulb, okay? I'm gonna move this here, and I'll move this light here. Oh, maybe it was directional. Hold on. My bad. So I'm gonna turn it, and then we'll go ahead and move it, but it's still, okay, there you go. Got a purple light on that one. I did have it the wrong way, guys. Sorry, we all make mistakes. So I'm gonna move it over here, and then, let's see. I think it still will be off or really dim though. Yeah, off. So that waterfall concept, you have series, and the bad thing about the series is that it's 3 waterfalls all under each other. The water goes in here, or the electrons are flowing through the first light, but then it's really strong on the first one, but if you were to add a second and a third, it just gets dimmer and dimmer and dimmer. So let's redo that really quick. I'll just move the wire so you can see it. If it's just 1, super bright, then we bring in 2, you see that dimness, they're still lit, but by the time I add 3, it won't even light anymore. Okay, so that's the answer to the series circuit. Okay guys, so that was the answer for the last series circuit lab. We're gonna go ahead and move on to the parallel circuit lab. What we're gonna do is answer these questions with the star next to them. Parallel, remember, means parallel lanes. So we're actually going to have multiple lanes for the electrons to flow on in a parallel circuit. Okay, so we're gonna build that. And then what we should see from our comparison before we started was that all the lights should stay the same intensity and brightness. We shouldn't see it dim like with the series. But remember, the negative of this is that the battery drains quickly. So let's go ahead and start. Okay, students, so to do parallel, we get rid of all of the extra links in the caterpillar, and we just still with one, almost like a butterfly. And then we just start putting the lights in side by side by side, making parallel lanes. So I'm actually going to change the viewpoint here in a second so you can see it better, like downward. But I turn the light on. Right away, we see really bright, really intense. So I'm going to change the angle so you can actually see the circuit and not me. Okay, so here we go. I've got one light on there. And then I'm going to put another light right next to it. But what's happening is that, remember, the electrons are coming off here on the red side, going through and then going through different options. And they are both just as bright. It's just the angle of the camera. They can either go down this lane or they can go down this lane. Actually, the LED light itself is conducting the electrons up and through. So now I'm going to put a third one on. We're going to see how many of these we can get. Here's a third one. All three just as bright. Super bright, man. It's blinding me. Putting in a fourth one. Still all four just as bright. Fifth one. All five just as bright. And then let's see if I can get one more in here. Sixth one. And that one also is just as bright. It's really bright, guys. So obviously these definitely work. We're just switching it around for you guys to see. So yeah, parallel works. It doesn't matter how many of them you put. They all are just as bright. So you can imagine that this is the way they do Christmas lights, right? We want that bright, intense light on our tree, and we don't want it to slowly trickle away. Also, if one of the lights comes out or breaks, everything keeps going. And that's also a benefit of parallel wiring. So let's go ahead and write that up. All right, guys, so parallel answers, here we go. As I said while we were doing this, 2 lights, same brightness as 1. 3 lights, same brightness as 1 or 2. Did it eventually get dim? No, they all stayed same brightness. We got up to 6 and they all stayed the same. Okay, so there's something else I wanted to show you with parallel circuits, and it's just, if you were to build these, sometimes it looks like things are getting dimmer. All right, so the parallel, I wanted just to show you that although when you put a ton of the lights in a parallel strand, it looks like it's getting dimmer. Remember, parallel lights shouldn't get dimmer. I just want to point out that it's only because you have the source right over here, and so the further the electrons have to flow, the dimmer it gets, but they still stay pretty strong all the way through, and so I did build it to show you that. So here you can see that this is the power source for the electrons coming in and out up here, and you can see that the further the electrons have to go, the lights get dimmer. Oops, there must be, oops, this just fell out, sorry. But they still stay pretty bright. It's just that they had to travel a further way. So it's just a little dimmer, not much, but you can definitely see here that these are brighter and dimmer. You don't need to write anything on this. It's just wanting to show you that, yeah, we could add a ton more lights in parallel. They're all pretty bright. And the image that you see of getting a little less down here is just because they have to travel a little farther, but they're all pretty bright still. So just something that you want to make a mental note of for that part. Okay, now what I have students typically do is just make your own and even mix the circuits, like make portions of something that's series, portions of something that's mixed, and then like make maybe a butterfly image and go crazy, try to do whatever you want. This is just an exploration part, and since you guys don't have access to this stuff, you can't really do that. So we're just going to skip the little exploration part, but just to know that, yeah, you can do really cool, crazy things with this. All right, guys, for this last section, I actually want you to answer these last three on your own. They're not difficult. They're just reflection questions. The first one says, what is the difference between series and parallel circuit? I would like you to make sure that you just go to the front. Refresh your brain one more time without my help. What's the difference between series, parallel? Keep in mind, like single lane highway, multiple lane highway, the cars are like the electrons. Look at the flow of the arrows to see how the electrons are moving. Compare, write up, but in short notes, not these. Try to do it on your own. That's number one. Number two, can you draw your own series and parallel circuits, each with 4 light bulbs? So I want you to do something like, this has 3, right? Can you do series and parallel with 4? What would you do if you had to do parallel versus series? You would keep the loop, but just drawing in another one. And here you would just add 1 more ring. So I'd like you to draw those out yourself. And then you'll be taking these photos and turning them into me. And last question here. Which type of circuit is better for hooking up multiple lights in your Play-Doh circuit, series or parallel? And I think you guys know this is parallel, right? All the lights are super bright, no matter how many we add on. That's like the question of which type of circuit would you like to have if you were doing a Christmas tree, right? And that's it for today. So I hope you now understand the difference between parallel and series for circuits. It does become important in the next section. We're gonna start applying some of these things with solar photovoltaics. So when you build solar photovoltaics, the way you wire all of the solar panels together, all the little solar cells, if you look closely on top of someone's house that has those panels, it's not just one big blue square or rectangle. If you look closely, you'll see that there's multiple little tiny squares or rectangle shapes. And then those are wired together. And we're going to look at the way they wire them, and it goes back to the concept of series versus parallel. To get efficiency, and also, you know, would you want a series hookup if you had part of your panel shaded without sun? We already know the series means like single lane highway, crash, everything shuts down, right? Or would you want multiple parallel options when you're doing the wiring of the little solar cells that are collecting the sun's energy? So that's just something to think about now. Just ponder on it, but we're definitely going to dig in deeper on that concept when we get into solar photovoltaics, which is the best alternative energy source because it's free sun all the time. The only thing you have to worry about is if you're in the winter or days like this with the rain. I had to come inside and do this because we had rain. But that's what batteries are for. And we'll actually do battery labs next year in chemistry. That's what the chemistry students are doing right now, is they're building their own battery. Oh, lights go out. That means time's off. Take care, guys. Hope you guys have a good week. Hope everything's going well for you. And just stay safe and keep going on your brain there. Get it strong. All right.